Hi, I'm going to talk about the first law of thermodynamics. The first law of thermodynamics is just a restatement of the general law of conservation of energy. So let's look at the model of conservation of energy and then we'll see how it applies to the first law of thermodynamics. So just like with force problems, energy problems, you need to define your system. So your system could be a person, it could be a block, it could be a box of gas, lots of different things that could be your system. So this circle here represents the system boundary. And the system itself can have different types of energy, such as potential and kinetic, a macroscopic types of energy that an object or system can have. And then we have thermal, chemical, and there are others, but that's what we'll confine our discussion to. These are the types of energy that a system can have. And then you have exchanges with the environment. You can have work coming in or out, a macroscopic transfer of energy due to a force being exerted over a distance, or you can have heat, a microscopic transfer of energy. Basically, it's happening at the molecular level. So things can get pretty complicated if you're having to keep track of 4 or more energy states and you're having to keep track of energy coming in and out. Typically what happens with the first law of thermodynamics, as usually written, is that we're assuming that potential, kinetic, and chemical energy either don't exist or don't change. So we get rid of those as zero or unchanging, and then conservation of energy becomes fairly simple. So the way we would write it is this, that any changes in thermal energy, the only change we're going to say is possibly occurring, would be equal to heat and work. Okay, so this is how you'll typically see the first law of thermodynamics written, but again, it just comes from this starting point of the general law of conservation of energy, and then assuming that some of these things are either zero or not changing. Okay, thank you for watching.